everyone. In this video, we are going to review the concepts from Chapter 7 to help prepare for your Chapter 7 test. So I'm just going to go through a few examples from each section. I have the sections labeled, so that way hopefully it makes it a little easier if you want to skip through the video to find the different parts that you need to go over. All right, so let's start with a Pythagorean Theorem problem. So we have two sides of a right triangle, and we need to find the third. We're going to do that using the Pythagorean Theorem. So the first thing we want to do is label A, B, and C. And C is always the side that is across from the right angle. And then A and B are kind of interchangeable. So we know that the Pythagorean Theorem is A squared plus B squared equals C squared. So 4 squared plus whatever x squared has to equal 10 squared. 4 squared is 16, 10 squared is 100. Subtract 16 from both sides, take the square root of both sides. Now, we're leaving our answer in simplest radical form, so we need to look for a factor of 84 that is a perfect square. In this case, that's 4. 4 times 21 equals 84. And then the square root of 4 is 2. So 2 root 21 is your answer. All right, so that's it for Pythagorean Theorem. Moving along, 7.2, state if the triangle is right, acute, or obtuse. In order to do that, we still need to label A, B, and C. Again, C is the longest side, and then A and B are the other two. So I like to make this table to help. All right, so C squared, that's going to be 8 squared. This is going to be 4 squared plus root 47. 64, 16 plus 47, still 64, and that's 63. So 64 is greater than 63, so that means this is obtuse. If C squared is greater than A squared plus B squared, we have an obtuse triangle. If C squared is less than A squared plus B squared, then it is acute. If C squared were to equal A squared plus B squared, then it would be a right triangle. So, it's always a good idea to, when you make this chart, to keep C squared on the left. That way you don't get confused about comparing them. All right. Now, these two problems come from 7.3. We're going to use two different theorems here, the geometric mean leg theorem and the geometric mean altitude theorem. Number 3 uses the geometric mean leg theorem, which says that the leg is the geometric mean between the whole hypotenuse and the piece of the hypotenuse that is closest to the leg. So that means 15 is the geometric mean between x and 9. So I just need to set up a proportion where 15 is diagonal, and then x and 9 are in the other spots. When I cross multiply, I end up with 9x equals 225. Divide both sides by 9, we end up with 25. Number 4 uses the geometric mean altitude theorem, which says the altitude is the geometric mean between the two resultant chunks of the hypotenuse. So number 3 is chunk to whole, whereas number 4 is chunk to chunk. So the altitude x is the geometric mean between the two pieces of the hypotenuse. When we cross multiply, we end up with x squared equals 144. Take the square root of both sides, and then the square root of 144 is 12. All right, so 7.3 deals with those two theorems. 7.4, we're talking about special right triangles. So first, I want to talk about 45, 45, 90. And I'm going to kind of draw your standard 45, 45, 90 down here. All 45, 45, 90 triangles look like this. The legs are congruent, and the hypotenuse is the square root of 2 times the leg. So you have two options. The first option is you're given a leg, which number 5 is. Since the legs have to be congruent, y also has to be 2. Once you have the other leg, you want to multiply the leg by root 2 to give you the hypotenuse. So in this case, this is our answer. The leg is the same. The hypotenuse is the leg times the square root of 2. Your other scenario is you are given the hypotenuse and you need to find a leg. When you are given the hypotenuse and you need to find the leg, you have to divide the hypotenuse by root 2. And then we don't leave our answers with a square root in the bottom, so we have to multiply by that same square root over itself. And that gives us 4 root 2 over 2. But 4 and 2 divide to be 2. So 2 root 2 is x. And because it is isosceles, y also is 2 root 2, because the legs are congruent. Okay. Now, 30, 60, 90 triangles. 30, 60, 90 triangles all look like this. The leg across from the 30-degree angle is the shortest side. And everything else is based off of that. The longer leg is just the shorter leg times root 3. The hypotenuse is the shorter leg times 2. So you have 3 different options. You could either be given the short leg, the long leg, or the hypotenuse. Number 7, you are given the long leg. And no matter what, unless you're given the short side, your first step should be to get the short side. So we're given the long leg, we're given the one across from the 60-degree angle. So in order to get the short leg, which in this case is y, I have to take the long leg and divide it by root 3. So y is just 6 here. And then to get the hypotenuse, which in this case is x, I just multiply the short leg by 2. So y equals 6, x equals 12. For number 8, you are given the hypotenuse. When you're given the hypotenuse, you want to get the short leg first, which is the side across from the 30-degree angle, so the short leg is y. So in order to get the short leg, when you're given the hypotenuse, you just divide by 2. So y equals 4. Now that you have your short leg, you can get the longer leg by multiplying the short leg by root 3. So y equals 4, x equals 4 root 3. All right, and last kind of problem, this is, I think, the easiest kind. You're given the short leg. You're given the side across from the 30. To get the long leg, you just multiply the short leg by root 3. To get the hypotenuse, you just multiply the short leg by 2. All right, so that's it for 7-4. 7-4 dealt with 45, 45, 90 triangles and 30, 60, 90 triangles. All right, 7-5 and 7-6 are going to split up into 2 kinds of problems. So the first kind is just given a right triangle, find the ratio in question. So for this, you want to remember SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So for number 10, we're trying to find the cosine of angle A. 40 is the leg that's adjacent. 41 is the hypotenuse. So the cosine of angle A is just adjacent over hypotenuse. The sine of angle Z, sine is opposite over hypotenuse. So here's angle Z, this is opposite, this is hypotenuse. So sine of angle Z is going to be 12 over 20, which simplifies to 3/5. We always want to simplify our fractions if we can. Tangent, tangent is opposite over adjacent. 12 is opposite. 35 is adjacent. Tangent of angle A then is going to be 12 over 35, which does not simplify. All right, so that's kind of like the first part of 7.5 and 7.6. The second part is using those ratios to find missing sides. So we're going to be given an angle and then two sides. So what we want to do first is label how the sides relate to the angle. This 14 is, sorry, I'm just trying to get a good view of the problem. This 14 is opposite. This x is adjacent. Tangent uses opposite and adjacent. So that means the tangent of 55 equals opposite over adjacent. Then we cross multiply, so we're going to get a x times the tangent of 55 equals 14. And so x is, x is 14 divided by the tangent of 55. And these directions say round to the nearest tenth, so we end up with 9.8. Make sure you're working in degrees and not radians. 14. Here's our angle. This x is opposite. This 17 is hypotenuse. So the ratio that uses opposite and hypotenuse is sine. So sine of 57 equals x over 17. Cross multiply. X equals 17 times the sine of 57. And when I punch that in my calculator, I end up with 14.3 after I round to the nearest tenth. 15. Oh, so sorry. 15. Here's the angle. 17 is adjacent. X is hypotenuse. So this one's going to be cosine. Cross multiply. Divide. And we end up with 40.2. All right, so that is it for 7.5 and 7.6. 7.7 is where we use inverse trig. We are going to be given two sides and we need to find the angle. So the way we begin this is kind of the same as before. We're going to label how the sides relate to the angle. So for number 16, 8 is adjacent, 21 is hypotenuse. And we need to say, okay, which ratio uses adjacent and hypotenuse? And that's cosine. So the cosine of question mark equals 8 over 21. Oh, that does not say 21. Sorry. So question mark then is going to be the inverse cosine of 8 over 21. Whenever you're given two sides and you need to find an angle, you want to do inverse cosine. And these directions say round to the nearest degree, so we're going to punch that in our calculator. And when we do, we end up with 68 degrees. 17, same kind of deal. This is our angle. Want to label the sides. We've got an opposite side and an adjacent side, so we are going to be using tangent. So I know the tangent of question mark equals 7 over 12. So question mark equals inverse tangent of 7 over 12. When I punch that in my calculator and round to the nearest tenth, I end up with 30 degrees. Okay, last one. Here's my angle. 19 is opposite. 54 is hypotenuse. Opposite and hypotenuse, I'm using sine. Sine of question mark equals 19 over 54. So that means question mark is the inverse sine of 19 over 54, which when I round to the nearest tenth, after I put it in my calculator, I end up with 21. All right, so that's everything from section or from chapter 7. So hopefully this helps you guys review a little bit.